All right, guys, I'm going to start talking about the immune system. And first, I'm going to talk about, the first, second, and third lines, which is kind of just an overview of all three of these things. And then we're going to get into detail, especially about that third line of defense. So, first, let's talk about the first line. This is your skin and all of its different features, pretty much. Think of it as like the barrier. Okay, this word underneath the first line, which is also underneath the second line, is called innate. This is the stuff that is non-specific. It will go after anything. It will protect your body against anything. Okay, and if you think about your skin, it protects just about anything from getting deep within you. Okay, but not only does the skin act as like that nice barrier there, but it also has like a lot of microbial like substances that are going to enhance its ability to protect you. For instance, the skin has a lower pH, okay, lower than neutral, and this lower pH makes it very unfavorable for bacteria and other substances to kind of like linger on your skin. Not all, but some. Okay, plus your skin, a lot of secretions from sweat, from oils, from sebum. All these things act as different antimicrobial things, again, that don't allow bacteria to grow along there. So secretions like sweat and oil and all those other things. Plus your tears and just the flow of the tears out of your eyes contains other antimicrobial substances that I'll mention later in the second line. But that flushing out of things, even the flow of urine out of your body, that flushing out, those secretions also help to flush things out. And then finally, there's the mucous membranes. Notice it's spelled mucus with an O-U-S. Mucous membranes produce mucus. M-U-C-U-S. Okay, mucus is the substance. Mucosal membranes are this membrane that it comes from. But the interesting thing about mucous membranes is not that they produce mucus, but also they have like tiny little hairs, and they're very geared towards like brushing things out, collecting things, and sweeping them out of those things. And you will find them lining like your respiratory, digestive, urinary. So let's put respiratory, digestive, urinary, as well as reproductive tracts. Okay, so all these things that have these systems that have like openings to the outside are coated by mucous membranes, which produce the mucus and also have endocilia for brushing and waving things out. So that's our first line of defense. And it's really, all of it is set up like a barrier to like wash things away, to keep things from getting in. All right, so now what if a substance like breaks that first line? They get in, okay? Well, then it's met by another set of innate substances or innate qualities that are going to like fight it off. And again, innate means it's going to fight off anything. It's not saying like, hey, you're chickenpox, I'm just going to go after you. Or hey, you're the flu, I'm going to go after you. Or hey, you're COVID, and I'm going to go after you. It goes after anything. And the first of these things are the phagocytes, the phagocytosis. These are your neutrophils. I call them the little eat 'em up guys, little eat 'em up guys, and the macrophages, the big eat 'em up guys. Eat 'em up meaning phagocytosis. Okay, in case you can't see that spelling, neutrophils, Neutro, and then Phils. And macrophages. Macrophages are also called monocytes. These are both two types of white blood cells. So you can see we're getting inside the body. So we're obviously talking about the blood now is going to be quite involved, and not the red blood cells, pretty much all the white blood cells. And a lot of the cells that we'll be talking about will be white blood cells that we're talking about, or the substances that come from those white blood cells. Okay, so phagocytosis is just really eating up some of those invaders that get in. Little eat 'em up guys, big eat 'em up guys. The second thing in the second line of defense are antimicrobial substances, or the complement system, sometimes called. These are different proteins that are produced mostly by B cells, such as basophils and eosinophils. did I say mostly B cells? Mostly white blood cells, basophils and eosinophils, that are going to produce a lot of substances. Interferon is one such substance, but there's a whole bunch of complements out there. And yes, you can say, yes, your hair looks good, and yes, oh, that outfit looks very pretty, and oh, beautiful, stunning eyes. We're not talking those kind of compliments. Compliments, though, are kind of like that. They kind of assist you and make you feel really good. Well, complement system are a bunch of proteins. Remember, these are all proteins. It's always all about proteins. Proteins that assist the immune system in doing its job. So they can't do it by themselves. I remember when interferon was first discovered way back in the early 80s, and they thought it was going to be the be-all, cure-all to all viruses out there, because interferon is one of those complement proteins that really latches onto viral reproduction. But they found out that it's just another one of these things, and there's something like, I don't know, 50 to 100, I want to say, different complement proteins out there. I might be wrong on that, but there's a lot of them out there. Okay. The next thing to talk about is inflammation. Everybody always hears, oh, take some Tylenol, or take some ibuprofen or Motrin or whatever, and you want to reduce the inflammation. Well, what is inflammation? Well, it's exactly what you see when, like, say you get bit by a mosquito, okay, and you have a little mosquito bite on your skin, and it itches, and it's red, and it swells a little, and sometimes it's even hot to the touch, and it even sometimes hurts a little bit, okay? That's all inflammation. And inflammation is an important thing. You want a little bit of inflammation, but when inflammation gets out of hand, then, you know, your body can't repair itself so well. So too much inflammation, not a good thing. But a little bit of inflammation is trying to do its job. It's trying to produce redness. That's just blood flowing to that area. Heat, it's trying to raise the temperature to increase your metabolism there. Swelling, all the swelling's coming from the rush of blood, both red blood cells as well as white blood cells. And then pain, the pain's there so that you will say, that your body will say, hey, take a rest, okay? It's hurting you, so sit down and take a load off your feet. The other thing that inflammation comes from is these white blood cells called mast cells. They release histamine that causes inflammation. And I know you sometimes think histamine, well, I've heard of antihistamines before. Yeah, antihistamines are taken usually when you have an allergy. You have an allergy, and histamine is being released by your body. And in other words, your body is responding to something like cat hair as if it's going to kill you. Cat hair is not going to kill you, but your body responds by releasing so much histamine, and it causes all this redness and swelling and itchiness and the flow of blood and pus and mucus and all that stuff that's going on. And so why do you take an antihistamine when you have an allergy? Because you want to suppress that. It's your immune system going berserk over like cat hair, which is not going to hurt you. But histamine does get released also when you're sick sometimes too. And sometimes people will take antihistamines to help themselves when they're sick from like the sneezing and runny nose and cough. And you want a little bit of that, but too much again can be not a good thing. So any too much of inflammation or any too much of histamine is not a good thing, because it's too much. Okay. And then finally, the last thing I want to talk about in the second line of defense, okay, are these natural killer cells. These are a type of T cell that isn't very specific. They see a bad guy, or they see like cells that are damaged in your body, and these cells might be saying, I don't have anything left in me, just kill me. And these natural killer cells literally go up and do that. They literally poke holes into these cells that are damaged, or cells that might be infected. They poke holes into them, and they cause apoptosis. That's like cell death. So think like cause apoptosis. And apoptosis is still something we haven't really talked about in detail, the signal transduction pathway, at least for it. But it's quite a systemized death of a cell. And when apoptosis gets triggered, there are certain steps that cell is going to go through. And natural killer cells will, sometimes poke holes and initiate that apoptosis to start. Okay. So we had our first line, and let me number these two. We had our skin, the pH of our skin, some secretions, and mucous membrane, so 4 things in the first line that really all together act as those barriers, okay, to keep things from getting in. Then our second line, once things get in, this is still innate, just like the first one, which means we'll go after anything. It's not specific in anything. These are your phagocytes and your antimicrobial substances, which are involved in the complement system, inflammation, and your natural killer cells. They go after anything. And most of these are involved with white blood cells. White blood cells such as mast cells releasing histamine, or white blood cells such as neutrophils and macrophage performing phagocytosis, or white blood cells that are releasing the proteins that complement this thing, or even another type of white blood cell, a type of T cell that causes apoptosis. They're all very general. They'll kill anything. They'll go after anything. But then there's the third line, and this is the line that's quite developed in your body, but a little slower to react. These first two things are definitely right out there. They're quick to react. These are a little slower to react. And this third line is called the adaptive immune system. Think they have to adapt a little bit. They have to take their time. This is also called the specific response because not only are they taking their time to react to any antigen like coming into your body, or some bad guy coming into your body, but they're also learning quite a bit about that, and they're going to hold on to that learning, kind of like you guys with this lesson. You're going to hold on to this learning for the rest of your lives, because you know what, if there is one system out there that's probably my favorite to talk about, it's probably the immune system. Now, this adaptive immunity is going to be like 2 types, and I like to call them the Marines and the Air Force. T cells are like Marines. Marines. My dad was a Marine, so I love those Marines out there. Marines are going to elicit what we call a cellular response, the T cells. And by the way, both T cells and B cells are kinds of what we call lymphocytes. Lymphocytes are another white blood cell, but if they're T cells, they're going to initiate a cellular response like Marines. They get down on the ground and they actually start doing the like fighting there. But B cells, I call them more like the Air Force. Okay, and I had quite a few cousins that were part of the Air Force, and Air Force, they fight in a different way. They usually fly over and like drop bombs. I always say these guys get down on the ground, do the killing themselves. These guys like fly over and like kind of elicit some sort of, ammunition that's going to like kind of do the thing. So we're going to get into more of those. And by the way, the B cells are called a humoral response. Okay. We're going to get into a little bit more of those in the next 2 videos. All right. So see ya.